A roller is shown in the figure, rolls over the surface without slipping, find the natural frequency of the system. Again, the same condition you can see. This is the roller is rolling at the point P. At the point P it is rolling, right? At the point P it is rolling. Again, you will see that the center is not fixed. So O is the center, it is not fixed. Okay. But here what is the change? The change is that the spring K and K, there are two springs which are connected at this point. Let I call this point as O dash. Now, in last problem, the spring was connected at the center. Okay, so obviously the natural frequency will be different in this case. Here, the springs are not connected at a center, but springs are connected at a distance O dash, such that O dash is equal to B. Right? So they have given you the distance. They have given. The springs are connected at the center O dash at a distance B from the O point. Okay, and then O to P distance. O to P distance is nothing but R. That is the radius of the circle is R, or the radius of the roller is R, and the mass of the roller is small m. Right? This is they have given. Is it clear? Have you understand what is the difference? The very important point. See, whenever you will be drawing that diagram, which diagram you will draw this triangle diagram, na? So that triangle diagram will change because the springs are not connected at the center. In last problem, the springs were connected at the center. So guys, you have to always be careful. Each and every problem is different. The concept is same, but logic, each and time you have to develop your own logic. Okay, there is no such fixed logic for each and every problem. Okay, you can just apply the method. So now we'll start. First of all, what we'll say? We'll say that let us x is the displacement given to the center of the pulley. Okay, now if x is given displacement to the center of the pulley. Okay, now this x displacement is not for the spring, right? In last problem, you have given a displacement x to the center, and the spring was connected to the center, so displacement of the spring was also center in the either direction. Okay, but in this case, this is not the case. Okay, because the center displacement is x, then the displacement of the spring will be in this direction. I don't know what is the displacement of the spring. Okay, I don't know what is the displacement of the spring. Okay, so that we have to calculate later on. What is the displacement of the spring? Okay, so we'll understand that point. Okay, now whenever you're applying a x as a central displacement, means what you're giving a displacement center to the mass m. Okay, this mass m will rotate about the point O. It will rotate about the point O. It will rotate about the point O by angle theta. Okay, right? Am I correct? It will rotate about the point O by angle theta. Sorry, where it will rotate? It will rotate about the point P or point O. Anyone? Where it will rotate?
Point P.
Point P. Okay. So basically, if you want to draw a free body diagram, how it will be? Let me draw a dynamic condition diagram, not in a steady state. Means what? I am giving a displacement. So let us say this is a center. Okay. So this is a center point O. Okay. Now you are giving a displacement x to the center point. I will change the color pen. So now I am giving a displacement x to the center point. So what will happen? Let me call this as a point P. So this, now I am first of all talking about a rotational point. Okay. So this is nothing but the angle theta. About point will be rotated by angle theta. Okay. Let us say this is somewhere a point. This is somewhere a spring point. Okay. So here you have a spring connected. Okay. So here you have a spring connected. This is a spring point. Okay. So here you have a spring connected. So this distance, what is this distance? B, and this distance total is nothing but the R. Right? See how I am drawing the diagram. The distance between the point O and O dash is B, and point P and O is R. Okay. This angle is theta. Okay. Now let me call this point as a dash. Let me call this point as a dash. Okay. Which point? This point. O dash, A dash. Let me call this as a point. And now, when you are giving a small displacement x to the center of the pulley is rotating about the point P by small angle theta. And now let us assume that the displacement of the spring is y. The displacement of the spring is y because the spring is not connected to the center. So the displacement of the spring will be different, and let us consider it as a y. Okay. Now from this figure, again, what is this distance? Again, what is this distance? O to A. Tell me what will be this distance? O to A. Anybody? O to A. O to A will be what distance? Anybody? I am giving a displacement x to the center, means O to A distance will be what? Yes. What will be the distance O to A? X, na? Because that is a translational distance. Because you are translating the center by distance x. Means what? Your CG is translating. Let us say this is O point is CG. You are getting here point G dash. So your center is not fixed. Means what? It is translating, right? So distance between the G and G dash is nothing but a x. Why x? Because we are giving x as a center displacement. So distance between the O and x is nothing but the x. So now you are getting a triangle like this. Okay, now we are getting a triangle like this. Let us say this is a point P. Okay, let us say this is a point O. This is a point A. This is a point A dash, and let us say this is a point O dash. So this distance is B. This distance is R. This distance is X. This distance is Y. I am saying what is the distance O to A? Y. Now what is O dash A dash distance? Y. Y means what? The displacement of the spring, because spring is connected at the point O dash. So from O dash to A dash, the distance will be Y. So Y X P, and this is nothing but the theta. Okay. Now apply the theorem. So what will you get? What is X? Anybody? Yes. What is X from this figure? X is equal to what? Now directly we will get from this diagram. From this diagram, I hope you have understood.
R theta.
R theta. And then what is Y? What is Y? What is Y? What is Y?
R plus B into X.
R plus B into theta. Theta. Okay. So now guys, you might have understand that the displacement of the spring is Y is equal to R plus B into theta, and the displacement of the center, that is X, is nothing but the means what? The displacement of the CG. Center displacement म्हणजे काय? CG चे displacement हे आहे R into theta. So in last problem, both the displacement of the spring and the displacement of the center was R into theta, but because spring was connected at the center. Okay. So if you are not able to apply the logic also, you can directly remember that if the displacement is equal to R plus theta, the distance is B, then it will be R plus B into theta. It is very, very simple. Now message me, have you understand this analysis or not? Have you understand this analysis? How I have done the analysis? Okay. Have you understand? Message please. Okay. Yes. So same. So now we'll solve the problem. I have explained you. Let X be the small linear displacement given to the roller of mass center O, means what I am giving at the center displacement X. Let P be the instantaneous center of rotation, means what about point P the pulley will rotate, and let Y be the displacement of the spring. So let us say Y is the displacement of the spring. So this is what we have done. Okay. So first of all, we have a translational diagram. Translational motion means what? The distance between the G and this distance is nothing but X. Means what? The center is displaced by X, right? Translational motion means what? G to D dash, the distance is X, okay? And then rotational motion. Rotational motion, this is nothing but a diagram what I have drawn. The distance between the O to A is nothing but a X, O dash A dash is Y, and OA is nothing but R plus B, okay? So from this I am getting X is equal to R theta. So X dot is equal to R theta dot, Y is equal to R plus B into theta. Okay, so this is nothing but a diagram which I explained you earlier. Okay, I hope you have understand this. See, the rotation is about this point P. Okay, you can take this as a point P also, or A also, whatever you want. Okay, rotation is about the point P, that is a theta. Distance between the O to P is nothing but a R. This distance is B. Okay, so I'm writing here B, I'm writing here R. This is X and this is Y. Okay, because at point O dash the spring is connected. So when this O dash will go to A dash, that will be the equal to Y, the displacement of the spring. Okay, here. Now tell me, according to the energy method, total energy equal to constant. Chalo. Now tell me, what will be the kinetic energy and what will be the potential energy? Anybody? Yes. Chalo. Kinetic energy of what? Roller. Yes, fast. Kinetic energy of roller, translational, rotational. Hello? Hello?
Rotational.
Only rotational. Center is not fixed. Means what? Kinetic energy of roller, translational. Yeah. Guys, try to remember that the roller is translating by distance x from the G to D dash. The center is not fixed. So kinetic energy of roller rotational plus kinetic energy of roller translational plus potential energy of a spring 1 and 2 is equal to constant, because we have a two springs K and K. So you have to consider both the springs. Okay. Now both the springs are actually in a parallel. Why they are in a parallel? Because they are connected between the two masses, between one mass, that is a pulley having a mass M. Okay. So you can either take K1 plus K2 or K plus K2K, or you can directly take, but better way, don't go into the confusion mode whether it is series or parallel. Take both the springs in the analysis. It is very easy, whatever it means. Okay. So chalo. Kinetic energy of a roller rotational plus kinetic energy of a roller translational plus potential energy of a spring 1 and 2 is equal to constant. Okay. So tell me what will be the formula one by one. So we have to solve number of problems. Na? So one by one formula. One of kinetic energy of roller translational. First of all, I will write translation. What is it? M into x dot square. Why m into x dot square? Because x is the translational, you can say displacement, because the CG is translated by x. Okay, plus rotational means what? 1 of I into theta dot square. It is rotated by theta. Plus spring 1 of k into y square plus 1 of k into y square is equal to c, because we have a 2 spring and the displacement of the spring is y. Very important. Okay, the displacement of the spring is y. Okay, so now what is x dot? X dot is nothing but r theta dot. You know that x dot is equal to r theta dot. Put it. I is equal to as it is. Okay, so we will put I afterwards. Okay, we will put I afterwards. Okay, then y. What is y? R plus b square. Y is equal to r plus b into theta. So y square is equal to r plus b square into theta square plus 1 of k into r plus b square into theta square. Okay. Now, anybody tell me what will be the I? Yes. What will be the I for this roller having a mass small m? Chalo. Anybody? What will be the I? This is point P. You have to use I at a point P or I at a point O. Last time I have already calculated. So you have to use IP or IO. Anybody? What you have to use in this problem? IP or IO?
IP.
Yes. IP ना. And so what is
IP.
IP? हाँ आपण IP already calculate केला. परत calculate करायची गरज नाही. IP किती असतो? What is IP?
3 mr
3 mr
square by 2,
right? Because this IP is nothing but the IO plus m into r square, and IO is nothing but the center. See, in the first two problems, the center was fixed, so that is why and the instantaneous rotation was O only. Here, the point P is the instantaneous center, so IO is nothing but the mr square by 2 plus mr square. So I am getting it 3 mr square by 2. So now we have no need to calculate I. You just use directly I 3 mr square by 2. Okay. So first of all, differentiate. Okay. Anybody? How will you differentiate? 1 of r into theta dot square. Okay. So how will you differentiate? 1 of m into r square 2 theta dot into theta double dot. Derivative of theta dot square 2 theta dot into theta double dot plus 1 of I as it is. Derivative of theta dot square 2 theta dot into theta double dot plus this is constant 1 of k into r plus b square. Derivative of theta square 2 theta into theta dot. Again derivative of theta square 2 theta into theta dot. Okay. Now here 2 will get cancelled. Theta dot will get cancelled. Always remember that 2 gets cancelled. Theta dot gets cancelled because theta dot is constant in all the cases. Okay. So similarly, I am getting here 1 of m square 2 theta dot theta double dot. Okay. And that what will happen? 2 will get cancelled. Theta dot will get cancelled. And finally, you are getting m square plus I theta double dot plus 2k, because this is k plus k 2k r plus b square theta is equal to 0. Okay. Now you know that IO is equal to m square by 2, IP is equal to 3 m square by 2. Put everything here. So put IO is equal to 3 m square by 2. Sorry, IP is equal to, here basically I is nothing but the IP. So finally you are getting 3 m square plus m square means what? 5 m square by 2 plus 2 krb square. So finally you divide this by, so you are getting theta double dot plus 4k. See now how it will become 2k r plus b bracket square divided by 5 m square, and this 2 will go up, so it will become 4k r plus b bracket square divided by 5 m square. This is the term you are getting here. This is the term, and this term is nothing but a natural frequency. So compare with the standard equation of simple harmonic motion, theta square plus omega n square is equal to theta. You are getting omega n is equal to 4k r plus b square 5 m square, and fn is equal to 1 upon 2 pi 4k r plus b square 5 m square. Okay. Now try to remember that those guys who are not considering IP is equal to 3 m square by 2, and they will go by book method and they will use a m square by 2. So here what will happen? It will become m square by 2. So m square means it will become 3 m square. So what will be the change in the answer? So their answer will be omega n is equal to square root of 4k r plus b square divided by 3 m square. So only change is that here it will be 5 and here it will be 3. So sometimes if you are using only m square by 2, and the answer will be 3 m square 2. So I am giving both the answers correct answer, because theoretically in book the theta displacement is very very small. That is why they are neglecting this parallel axis theorem and they are using the m r square by 2 only. Okay, is it clear? So that answer will be 3 m r square by 2. Okay. Now tell me, have you understand the problem or not? Chalo, message me, have you understand this problem? So I will move on to the next problem. Problem number 5. We have to solve lot of problems. कोणाला काही डाउट आहे या प्रॉब्लेम मध्ये? So now I will slightly now both the problems which I have solved. First two problems were a vertically suspended mass to a pulley but center fixed. Then horizontal masses or horizontal roller rolling on a horizontal surface, but center is not fixed. Now this problem is what? Find the natural frequency of a system. Here again the mass m is suspended to a pulley vertically. Okay, so this is vertically suspended mass, but the center is not fixed again here. Okay, now again slightly the concept will not change, but the logic will change. Okay, chalo, how will you start? First step. Now I want to answer from your side. Till now we have solved 4 problems. Let us see how do you solve. Yes, what is the first step? What is the first step which I always do? Yes, what is the first step? What is the first step? This system is a static state no? Under the static condition. You have to make the system. You have to make the system dynamic. Means what? Let x be the small displacement given to the mass m. Means what? I am giving a mass m displacement. So now when I am giving a mass m as a small displacement, what will happen? What will happen? What will happen? Yes. When I am giving, what will happen to this pulley? What will happen to this pulley?
Rotation anti-clockwise.
No, but rotate by what? Rotate by theta. Where? What will be the instant? Now I want to answer from
Pulley will translate downward.
Okay, that is okay. Pulley will translate downward because pulley is not fixed. Okay. So as you say that, I am drawing a diagram over here. Okay. So let's start. So this is a diagram. Okay. So let us say this is a center. Okay. Now this is a center point. Okay. Now this is a point O. Okay. At point O, I have a spring connected. Okay, so at point O, I have a spring connected. Okay, this is a point O. Okay, and now here you have a mass. Okay, here you have a mass M. As I say that it is X. Okay, now tell me what will happen to the pulley. Yes, where it will rotate. What will be the instantaneous center of point? Where will be at what point the pulley will rotate by angle theta? Okay, you are correct. That pulley will rotate like this. Pulley will rotate like this. Okay, it will rotate by theta like this. So what will be instant center of point O or something another point? This is what logic you have to understand, my dear students. Tell me what will be the point of rotation, point of instantaneous center. Which point? O point?
Center O.
How center O? The center O is not fixed, na? So will it rotate at center O? And here at this point the mass is connected. So here you are getting a jerk, you are getting a fall. So it will rotate at this point, na? It will rotate at this point. Okay, it will rotate at this point. The center is not fixed, so it will rotate at this point and the pulley will become like this. So let me call this as a point as a. So A will be the instantaneous center of rotation and this will rotate at the like this. So this pulley will rotate in a downward direction, that is in a anti-clockwise at the point O. It will not rotate at O because the center is not fixed. And what will happen here? Center, initially the center was G, it became a G dash. So this distance is nothing but this distance is, let us say something, this distance G to D dash is nothing but a translational distance. Okay, so this will happen to the pulley. Okay, now tell me, let me call this as a point 1, let me call this as a point 1, let me call this as a point 2. Now tell me, I will draw a figure here, I will draw this triangle. Now see how it is very very important in the pulley problem, how you connect the triangles. So let me draw a triangle here. Now this is a triangle which has been created. Have you understand or not, first of all, how the pulley is rotated? Okay, so let us say this is a center point, let us say this is a G, this is G dash, let us say this is a point, let us say this is a 1 point and 2 point. Okay, now we know that 1 to G, this distance is R because this is R and this is R. Let us say R is the radius of the pulley. So G to is nothing but R. Now tell me what is the distance 1 to? What is the distance 1 to and what is the distance G dash? It is same or different? Anybody? What is the distance 1 to? The distance between the 1 and 2 will be how much? Anybody?
2r theta.
No, man. First of all, in terms of x or y, I'm asking. In terms of x and y, what is the displacement of a mass m? What is the displacement of a mass m x? मग जेवढा मास तुमचा x खाली जातोय तेवढाच तुमचा हा 1.2 ला येणार आहे ना. So distance between the 1 and 2 will be x, right? Because whenever you're pulling a mass by x, the point 1 will move towards the 2. By what distance? X only. So a 1 to 2 will be x. Now tell me the distance between the g and g dash will be same as the x or not? एवढं सांगा फक्त सेम असेल की नसेल. Distance between the 1 to 2 and g to g dash will be same or different? X or different something? Yes. The distance between the 1 to 2 is x. So distance between the g and g dash will be x or not? See, in last horizontal problem, I was giving a x as a displacement to the center. So the translational distance was x. But here I am not giving a displacement to the center. Here I am giving a displacement to this mass m. And again, this pulley is not fixed at a center. So this distance is x. So distance between the g and g dash, let me call it as a y. It is not the same, first of all. Okay, so distance between the 1 to 2 is x. So let us say that the distance between the g and g dash means what? The pulley central displacement is y. Now message me, have you understand this? See, each and every problem have a different concept. You have to understand. Message me, have you understand or not this? Yes? Have you understand this or not? Hello? Anybody? Hello? Is it clear? Okay. Okay. Now if it is clear, what is this? This is theta. Now tell me, what will be the x? Now someone have told what is that x? It is correct. X is equal to what? What is x? In terms of theta? Yes, someone have answered. What is x?
2r theta.
R theta, right. And what is y? What is y?
R theta.
R theta.
R theta. Okay. Now y is equal to r theta. See, why? Basically, when the pulley is suspended in such a way horizontally, instantaneous center is A. Try to understand that the center of the pulley distance is not same as the distance between the 1 to 2. Okay. In last two problems, I have given the displacement to the center only. That was the difference. Okay. So now, if x is equal to 2r theta, y is equal to r theta. Now you can see that from these two relation, I will get a relation. What is the relation between the x and y? X is equal to what? 2 into y. Or y is equal to x by 2. Okay. Means what you have to always remember that the displacement of a center, that is a g to g dash, is approximately always half of the displacement of a mass m. That is means what? If the displacement of the mass m is x, then the displacement of the center of the pulley, that is a g to g dash, is always x by 2. Always. In any problem which is having such type of orientation. Okay, in such type of problem, always it will be x by 2. And what is x by 2? It is nothing but a y. But approximately, okay, approximately it is y. Practically it may vary beyond x by 2 or above x by 2. Okay, beyond or beyond. But theoretically it is always x by 2. Now message me, have you understand this concept? See, in pulley diagram, it is very, very important that you should able to draw this triangle. From triangle, it makes it easy to understand. चलो, आता मला सांगा तुम्हाला एक कळलं असेल तर आपण सॉल्व करूया प्रॉब्लेम. Have you understand this? Shall I move forward? Have you understand this? Okay, thank you. चलो, so I'll rub out this and I will start. Okay. So same diagram I have drawn here. Let x be the small displacement given to the mass m. Therefore, pulley will rotate by angle theta as well. It translates its CG as the center of pulley is not fixed. Let y be the center or CG displacement of the mass m. Okay. So y means what? Y is nothing but the displacement center. Okay. So now this diagram already I have explained. This diagram I have drawn. 1 to 2 is x, g to g is y. So y is equal to r theta, x is equal to 2r theta, or theta is equal to x upon 2r. Okay. From this you are getting, if you want to convert theta into the x into theta, it is theta is equal to x upon 2r. If you want to convert, or you can write like this, theta is equal to y upon r also. So vice versa you can convert in any form. For example, if they have asked you m equivalent, use x. If they have asked you I equivalent, use theta. Okay. So that you know already. I have solved the problem on it. Okay. So this is very important. Y is equal to x by 2. Always remember that. Or x is equal to 2y. In the next problem, I will directly use this relation. X is equal to 2y or y is equal to x by 2. I will not do this analysis again. This you have understand here already. Okay. So let's solve the problem. So now tell me, according to the energy method, energy method. So tell me, kinetic energy of what? Kinetic energy कोणाकोणाची येणार याच्यामध्ये? इथे सांगा. चला. Kinetic energy of mass m. Mass m म्हणजे हा small m. Translational rotational. Hello. Translational. Okay. Plus kinetic energy of pulley. Kinetic energy of pulley. What will the kinetic energy of pulley? Translational, rotational, both. Kinetic energy of pulley. Translational, rotational, both. Anybody?
Both.
अरे एवढा वेळ लागतो तुम्हाला समजत नाही का?
Both, sir.
Both. Rotational, rotational plus translational आणि plus kinetic energy of potential energy of spring. ओके. आता एक पॉइंट सांगायचं राहिला. मला सांगायचं स्प्रिंगचं डिस्प्लेसमेंट किती असणार आहे? x or y. What will be the displacement of the spring? Spring कुठे कनेक्टेड आहे बघा आणि व्यवस्थित उत्तर द्या. What will be the displacement of the spring? X or y? Y.
Y.
Because it is connected to the center. Why? Because the center displacement is y. So we could displace it. Spring should displace downwards or upward? Downward. So because if the spring will get compressed, because pulley center is moving downward, so spring will get elongated. Okay. So the displacement of the spring is also y. Displacement of the center is y, and displacement of the mass is x. Okay. हे सगळं आपण थीटाच्या फॉर्म मध्ये कन्वर्ट करणार आहोत. डझंट मॅटर. ओके. तर चलो. सो कायनेटिक एनर्जी ऑफ मास m ट्रान्सलेशनल प्लस कायनेटिक एनर्जी ऑफ मास कॅपिटल m दिलाय ना त्यांनी, म्हणून मी कॅपिटल m घेतलाय. रोटेशनल प्लस ट्रान्सलेशनल इज इक्वल टू कायनेटिक एनर्जी टोटल. ओके. आता हे मी काय करतो, इक्विव्हॅलेंट मेथडनी सॉल्व्ह करतो. ओके. नाव आय विल नॉट यूज द डिफरन्शिएशन मेथड. ठीक आहे. जस्ट असं काही नाही, तुम्ही डिफरन्शिएशन मेथड वापरला तरी चालेल, पण जस्ट एक आपण इक्विव्हॅलेन्स मेथड वापरून बघूया, बिकॉज यू normally find it easy, right? So what is kinetic energy total? 1 of mx dot square translational plus 1 of my dot square, because see it's a capital Y and center. Translational म्हणजे काय बघा, तुमचा पुलीचा सेंटर आहे, तुमचा पुलीचा जो सेंटर आहे तो कितीने ट्रान्सलेट होतो? y ने ट्रान्सलेट होतो. म्हणून मी ट्रान्सलेशनल काय घेतली? y घेतली. हे लक्षात घ्या, व्हेरी इम्पॉर्टंट. सो 1 of my dot square आणि रोटेशनल 1 of I theta dot square. ओके. आता मला एम इक्विव्हॅलेंट काढायचं किंवा आय इक्विव्हॅलेंट, व्हॉट एव्हर जे तुम्हाला आवडेल ते कॅल्क्युलेट करा. ओके. बघा. सो आता मला सांगा तुम्हाला काय करायचंय. जर एम इक्विव्हॅलेंट किंवा आय इक्विव्हॅलेंट कॅल्क्युलेट करायचं असेल तर तुम्हाला एका फॉर्म मध्ये आणायचंय. बरोबर. लेट अस से आय एम फाइंडिंग एम इक्विव्हॅलेंट. आता त्यांनी काहीच म्हटलं नाहीये की एम इक्विव्हॅलेंट काढा, किंवा त्यांनी फक्त नॅचरल फ्रिक्वेन्सी सांगितलंय. सो आय कॅन फाइंड आउट एम इक्विव्हॅलेंट आणि आय कॅन फाइंड आउट आय इक्विव्हॅलेंट. ओके. लेट अस से आय एम फाइंडिंग एम इक्विव्हॅलेंट. So I want all the terms in x. Okay. So what is y? Y is nothing but what? Y is nothing but x by 2. Or y dot is equal to x dot by 2. So put y dot is equal to x dot by 2. And what is theta? Theta is nothing but, already we know that x is equal to 2r theta. So theta is equal to x dot upon 2r. So put theta is equal to x dot upon 2r. Means guys, what I have done to find m equivalent, I have to take only one parameter, x. ओके. जर मी तुम्हाला म्हटलं असतं आय इक्विव्हॅलेंट काढा, तर तुम्ही काय केलं असतं, या एक्स ला थीटा मध्ये आणलं असतं, वाय ला थीटा मध्ये आणलं असतं, आणि थीटा आहे तसं. ओके. इज इट क्लिअर? इट्स एव्हरीथिंग वन अँड द सेम. ओके. चलो. सो फायनली मला काय मिळालं, आय हॅव गॉट 1 हाफ कॉमन, एक्स डॉट स्क्वेअर कॉमन. आतमध्ये काय झालं, स्मॉल एम प्लस कॅपिटल एम बाय 4 प्लस आय अपॉन 4r स्क्वेअर. ओके. सो नाव यू नो दॅट व्हॉट इज आय. या अगेन आय हॅव टू मूव ऑन. नाउ टेल मी व्हॉट इज आय. You have to find out IA. IA means what? A about the point O. So what is IA? So IO plus mr square. So that will be equal to 3 mr square by 2. Again remember that, because you have to find this I, mass moment of inertia about, because mass moment of inertia about point O is mr square by 2. Right? Is it clear? Okay. So put everything here. So same they have put I is equal to mr square by 2. So I is equal to 3 capital M दिला त्यांनी, म्हणून capital mr square by 2. हे सगळं याच्यामध्ये पुट करा. So I'm getting k is equal to 1 of m into capital M by 4, 3 mr square by 2 plus 1 by 4 r square x dot square. So r square will get cancelled. R square will get cancelled, and what you will get? Okay, what you will get? Capital M by 4, small m, 3m by 8, and finally you are getting m. Okay. So k is equal to 1 of m equivalent to x dot square. So you are getting m equivalent is equal to small m plus capital, small m plus capital 5m by 8. Okay. So here I have find out m equivalent. So this problem you can also solve by the differentiation method, but I have solved this problem by the equivalence method just for the change. Now tell me, have you understand this? Is there any doubt in this? Similarly, you find out the k equivalent, and then you will directly get omega n is equal to square root of m equivalent upon k equivalent upon m equivalent. Okay, so this method is also easy method. So tell me, have you understand? Message me the same. Okay. Okay. Now potential energy of the spring. Now potential energy of the spring is what? P is equal to K into y square. But what is y? What is y? Y is equal to x by 2. Okay. Because I want to bring everything into the x. Na? तुम्ही kinetic energy चा formula काय बदला? 1 of m equivalent into x square, x dot square. So potential energy will be what? 1 of k equivalent into x square. So I want to bring x square. So y is equal to x by 2. So y square is equal to x by 4, x square by 4. So finally what you are getting? Finally what you are getting? Very simple. Problems are very simple once you understand the logic. So k equivalent is equal to 1 by 4 from this formula. Okay. And then my final answer. Omega n is equal to square root of k equivalent by m equivalent. Put everything k upon 4 m plus m by 8. So make a multiplication. What you will get? 8m plus 5m upon 4 to the 8. So 2k 8m plus 5m. So this is your final answer. Okay. So now tell me, have you understand this or not? So I can move forward. Have you understand? हॅलो प्रॉब्लेम समजलाय का पुलीचा? तो अजून एक लास्ट प्रॉब्लेम मी पुलीचा घेणार आहे अँड देन आय विल स्टॉप अँड देन विल मूव ऑन टू द नेक्स्ट स्टेप. एनी डाऊट, कोणाला काही डाऊट असेल तर मला आत्ता विचारा, because you have to solve a different types of problem in your assignment and the exams also. Is it clear, everyone? Okay. So this is how we have to solve a number of problems. Okay. Now this is the different type of problem again. Now till now I have considered a vertical pulley. Okay. I have solved a problem on vertical pulley. I have solved a problem on horizontal pulley. Okay. Horizontal pulley. Then I have solved a problem on center fix, center not fix, center fix, center not fix. Okay. So we have solved almost 4 types of problems. Normally we have solved 5 out of which 4 types of problems I have covered. Okay. Now we move on to another type where 2 pulleys are connected together with a mass m. Okay. Now this problem I will solve by D'Alembert's or Newton method. Okay. Because already I have solved a lot of problems from the energy method. This problem I will solve by the D'Alembert's or the Newton method. Okay. Is it clear? Just for the change, because they are not expecting. They are just expecting find out the natural frequency Fn is equal to 1 upon 2 pi square root of Kn. So always it will be in terms of K and N. So let us start with now how you can start with. Okay. Now basically this center which I have drawn by this red color, that is actually not given. Okay. This problem is only, you can say just they have given you the pulley 1 and pulley 2. Okay. Now to solve this, first of all let us consider something. Okay. So how will you start? Okay. So we'll say that let x is the displacement of the mass m. Okay. Let x is the displacement of the mass m, right? So let x is the displacement of mass m. Okay. Mass m ला आपण x displacement केला. So 1 to 2 हे distance किती असणार आहे? कोणी ते सांगाल मला? 1 to 2 again same. Instantaneous center तुमचं काय असणार आहे? Let us say this is the instantaneous center point O. This is the instantaneous center point O. Okay. Now जेव्हा तुमचा mass m x ने displace होतोय and the mass m will displace by the x, this pulley center let us say will displace by x1. So what is x1? x1 is nothing but a displacement of the pulley center 1. Okay. आता ही तुमची पुली कशी डिस्प्लेस होणार आहे? अशी होणार आहे थीटा. ओके. मीन्स व्हॉट इट विल बी इन अ डाउनवर्ड डिरेक्शन, अँटी क्लॉकवाईज. आणि ही पुली तुमची कशी होणार आहे डिस्प्लेस? ही तुमची अशी वरती होणार आहे इथून. ओके. इथून अशी होणार आहे वरती. सो लेट अस से x2 is the displacement of the pulley center 2. Is it clear what I am trying to see? See, I am explaining again. Let x is the displacement given to the mass m. Okay. So the distance between the if I this is same. If this is a pulley, if I draw a diagram like this, okay, similarly, okay. let me call this as the point G. Okay, let me call this as a point O. So same whatever हा प्रॉब्लेम समजण्यासाठी तुम्हाला आधीचा प्रॉब्लेम घेतलाय. ओके, म्हणजे हा आपल्याला कंबाईन सॉल्व्ह करायचा आहे. लेट अस से असं आहे. So let me say that this is a point 2 and this is a point 1. Okay, and this is a point G dash. So this is theta. So let us say that the displacement of the mass m is x, right? So what will be the distance between the 1 to 2? The distance किती असणार आहे? 1 to 2 distance किती असणार आहे? Anybody? What will be the distance 1 to 2? आताच सांगितलं ना किती असणार आहे? जर x हे mass m चं displacement असणार आहे, the displacement of a point 1 to 2 will be what? Anybody? X. Then what will be the displacement of G to D dash? Let me call it the x by 1. And here आपल्याला माहिती आहे what is x by 1? X upon 2. हे आपण बघितलं ना. The displacement of a center of a pulley is approximately half of the displacement of this 1 to 2. Okay, कारण आपण जर हा ट्रायंगल ड्रॉ केला, असा ट्रायंगल ड्रॉ केला, तर मला काय मिळणार? हा जर माझा x1 असेल, हा माझा x असेल, म्हणजे हा x by 2 असेल थोडक्यात. ओके, हे आत्ताच बघितलं आपण, राईट? So that is why I am considering x as a displacement of mass m1 and x1 as a displacement of this center of the pulley 1. So similarly, ही पुली तुमची अशी डाउनवर्ड मूवमेंट होणार आहे, तर ह्या पुलीची तुमची अशी मूवमेंट होणार आहे, राइट? So this will be nothing but the theta. So let's say that x2 is the displacement of the pulley 2. Okay. Now, basically, guys, try to understand that if you want to solve this problem by D'Alembert's or Newton's method, there is one more element which you have to consider, that is nothing but a T, and let us say that T is nothing but the tension in the cord. Okay, while solving a problem by energy method, we are not considering a tension because we are interested only in the energy. But while solving a problem on D'Alembert's and Newton's method, you have to, because see, this mass M is connected this pulley by the T, this is connected by the T, this is connected somewhere by the T, because there is tension in this cord. Na? Whenever you are applying a displacement to the mass M, this mass M is rotating the pulley with the help of the cord. So there will be some tension inside the cord. We have already solved the problems on the tension in the kinematics of machinery. So let me consider that T is the tension in the cord. Okay. So see how many things I am assuming here. Okay. So for pulley 1, let me first of all draw an diagram. Okay. Okay, so what is the diagram for the pulley 1? Same, this is the diagram for the pulley 1. Okay, this will move like this. Pulley 1 म्हणजे हा, ह्याच्यासाठी काय असणार आहे? हा पॉइंट माझा O झाला, हा पॉइंट मी 1 म्हटला, हा पॉइंट मी 2 म्हटला. This is let us say x, and let us say this is x1, and this is a G, and this is G dash. Okay, and now what does the theory says in the last practical? That x1 is equal to x by 2, means you can write x is equal to 2x1. Is it okay? So what is x? X is nothing but a 2x1. आपण मागेच बघितलं ना, x is equal to 2y. मी फक्त आता x1 x का घेतो, कारण माझ्याकडे दोन पुली आहेत, म्हणून मी x1 आणि x2 दोन व्हेरिएबल घेतले. अदरवाइज मला काय करायला लागेल, इथे y आणि इथे कुठेतरी z घ्यावं लागेल. मग एवढं कॉम्प्लिकेशन करण्यापेक्षा मी x1 आणि x2 घेतो. ठीक आहे, चलो हे तुम्हाला क्लिअर झालं. आणि पुली 2 ची मुवमेंट कशी असणार आहे? हे पुली 2 ची मुवमेंट कशी असणार आहे? 1 to 2 x असणार आहे, बिकॉज जेवढं डिस्प्लेसमेंट मास m ला देतो तेवढं डिस्प्लेसमेंट इथे x येणार आहे, इथे तेवढं येणार आहे x. सो 1 to 2 is x, and let us say that g to g dash is x2. g to g dash is x2. ओके, मग ह्याच्यानं मला रिलेशन काय मिळणार आहे? ह्याच्यानं रिलेशन काय मिळणार आहे? x is equal to twice x2. ओके, सो I have got two relation, x is equal to twice x1. ओके, आता मला सांगा इथपर्यंत तुम्हाला कळलं का? म्हणजे मी पुढे जातो. Please message me. Have you understand till this particular point what is x and what is x2, 2x2? How I have done? See, whatever concept I have used in the last problem, same concept I have used in the another problem. Same problem, this one. Okay. Tell me, have you understand? Please message fast so I can move forward. Clear? Okay. So now try to understand that whenever the pulley is suspended in such a manner, you have to draw diagram in this way. Okay. Now basically guys, while solving a problem, you have to assume only one. Imagine that, आता तुम्हाला काहीतरी imagine करायचं solve करताना. What you have to imagine? Imagine that only pulley, forget about this pulley and imagine that only there is a motion in the pulley 1. Means what? Imagine that this pulley 2 is fixed. Then what is the motion in the pulley 1? Okay, and then secondly imagine that this is fixed and then this is moving. Okay, and then imagine that both are moving. Okay, because if you consider both are moving, you cannot get some equation. Okay, so to get some equation, we are considering pulley 1 as a fix. I will get equation for the pulley 2. Then I am considering pulley 2 as a fix, and then I am getting equation for the pulley 1. And then I am combining both the equations, assuming that both the pulleys are moving, because in the problem you can understand that both the pulleys are moving. Okay. So first of all, let P is equal to tension of core, X is the displacement of mass M1, X1 is equal to displacement of pulley 1 center, and spring 1. Yeah, this I forgot to tell. Now this pulley 1 center is the spring 2K is attached to the pulley 1 center, so it's a displacement for X1 असणार downward. Okay, and ह्याचा displacement upward असणार आहे X2. कारण center was connected आहे, बरोबर? ठीक आहे. Next. Now for pulley 1. Okay, so when pulley 1 is assumed to be fixed, assume that when pulley 2, assume that pulley 2 is fixed. आपण solve कसं करतो बघा. Assume that pulley 2 is fixed. So means what? Pulley 1 is moving. So what relation you are getting? You are getting X is equal to 2x1. X is equal to 2x1, right? Because I have already explained that the displacement of the center is half of the displacement H. Okay, so this is the first relation I am getting. Second relation. Okay, assume that now pulley 1 is fixed. Now assume that when pulley 1 is fixed, means what? Pulley 2 is moving. So for pulley 2, what you are getting? X is equal to twice x2, means x2 is equal to x by 2. Okay, हे relation मला मिळालं, बरोबर? मग when both the pulleys are moving, तुम्हाला relation काय मिळणार? X is equal to twice x1 plus twice x2. Okay, म्हणजे हे just understanding साठी मी घेतलंय, and this is my final relation. So what I mean to say is that guys, हे derivation मधून मला काय मिळालं? जेव्हा तुम्ही x हे displacement देताय. See, we are solving problems on a single degree of freedom system. I only want one parameter. I don't want all the parameters. Okay, coordinates, for example. So I have to get a relation between the x, x1, and x2. So till now we have only two coordinates, x and theta, or maybe x and y, and we got a relation. Now here we have a three, x, x1, and x2. Okay, so I got a relation x is equal to 2x1 plus 2x2. Right. So if you are giving a small displacement x to the mass m, that will be equal to the displacement of the twice the displacement of the pulley center plus twice the displacement of the pulley center 2. Okay, असं मला हे रिलेशन मिळालं. समजलं असेल तर मला प्लीज मेसेज करा. You understand this? Okay, so when both the pulleys are moving, I am getting x is equal to twice x1 plus x2. Okay, आणि x is equal to 2x1 आणि x is equal to 2x2 हे कसं आलं हे तुम्हाला आता कळलंय आतापर्यंत. Is it clear? Is it clear, guys? Hello. Is there any doubt? Anybody is having any doubt in this problem? Okay. So now consider the FBD of pulley 1. Okay. आता मला पुलीची आता आपल्याला DNMS प्रिन्सिपल सॉल्व करायचे ना प्रॉब्लेम. म्हणजे आपल्याला सगळ्याची FBD काढावी लागेल. एनर्जी मेथड मध्ये आपण FBD काढत नव्हतो. So draw the FBD of pulley 1, pulley 2, and mass m. Okay. So I will draw fast the FBD. Okay. Now see how will be the FBD of pulley 1. Let us talk about the pulley 1. So this is pulley 1. Okay, so pulley 1 is connected to the two cords. Okay, so this is nothing but a tension 1 T. T will be in the downward direction. Again here, see here we will have a T. Here we will have a T. Okay, so this is the FBD of the pulley T and T. And at the center, what will be the opposite force at the center? 2K x1. X1 is the displacement of the spring. That is the displacement of the center x1. And you know that the spring force always acts opposite to the displacement. Displacement x1 is downward, so this 2k x1 will be opposite. Okay, is it clear? So this is the FBD for the pulley 1. Now FBD for the pulley 2. FBD for the pulley 2. Yes. FBD for the pulley 2. How will you draw the FBD for the pulley 2? Yes, anybody? Okay, chalo, I will show. Okay, so I have drawn this pulley 1. Okay, so now here you know that for pulley 2 the motion is upward. Okay, x2 is upward, so the spring force 2k x2 will be downwards, and here the motion x1 is downward, so 2k x1 will be upward. Okay, so in this way I have drawn a FBD for the two pulleys. So considering the FBD of pulley 1 and 2, what I will get? See, T plus T. 2t. So 2t is equal to 2kx1. Why 2t is equal to 2kx1? Because both are in opposite direction. Similarly, for pulley 2, 2t is equal to 2kx2. Right? See, that is why I have told that whenever you are solving a problem by D'Alembert's principle, slightly it is a complicated because you have to solve the draw the FBDs. Okay, but you should know how to solve. Okay, now so from equation 2 and 3, 2t will is a constant, 2k is a constant. So I am getting that x1 is equal to x2. Okay, so this analysis, from the analysis, I understand that the center displacement of the pulley x1 and the center displacement of the pulley to x2 is equal. Okay, so this is the first thing which I am cleared. Okay, हे मला clear झाल्याच्यावर next. Now putting in equation 1, what is equation 1? X is equal to 2x1 plus 2x2, right? So now x1 is equal to x2. So put this x2 is equal to x1. You are getting x is equal to 2x1 plus x1. So means what, we are getting x is equal to 4x1. So x1 by x2 is equal to x by 4. आता आता फार महत्त्वाची गोष्ट आहे मित्रांनो, बघा जेव्हा एकच पुली कनेक्टेड होती, when there was a one pulley connected, I have understand that x, the displacement x, that is, let us say center displacement of y was equal to x by 2 when there was a one pulley. But in this case, since there are two pulleys interconnected to each other, मला इक्वेशन काय मिळते बघा, x1 that is center displacement is equal to center displacement 2 is equal to x by 4. So I am not getting x by 2, I am getting x by 4. So means what? Whenever the two pulleys are connected together, you cannot directly predict that this y is equal to x by 2. Okay, you have to do all the analysis and then you get x1 is equal to x2 is equal to x by 4. Now have you understand this? So if x1 is equal to x2 is equal to x by 4, now you know that from this equation 2t is equal to 2k into x1, right? 2t is equal to 2k into x1. Let me say that 2 gets cancelled. So t is equal to k into x1. But what is x1? X by 4. So I am getting t is equal to kx by 4. So now from this you can also calculate the tension in the cord. So what is the tension inside the cord? That is k multiplied by x by 4. Okay. So I have got x1, x2, I have got t. आता हे सगळे पॅरामीटर्स तुम्हाला मिळाले की तुम्हाला काय कॅल्क्युलेट करायचे नंतर D'Alembert's principle. Okay. Now consider the FBD of mass m. Okay. Now consider the FBD of mass m. आता मला तुम्ही सांगू शकाल हे खूप सिंपल आहे. मास m ची मी FBD काढतो. ओके. दोन्ही पुलीची FBD ड्रॉ केली. Now mass m. What is the motion of mass m? Downwards. So let me say that I have to apply D'Alembert's principle. So for D'Alembert's principle, now mass m is connected to what? पुली. मग या पुलीमध्ये टेन्शन कुठे असणार आहे? इथे असणार आहे, अपोजिट. तर टेन्शन असं असणार आहे मासचं. ओके, कारण अशी पुली आहे ना कनेक्टेड, बघा अशी कनेक्टेड आहे, हे बघा ही अशी कनेक्टेड आहे पुली, तुमची मासला अशी कनेक्टेड आहे, बरोबर. या मास एक्स खाली आहे, म्हणजे ह्या पुलीचं टेन्शन इथे असणार आहे आणि या मासचं टेन्शन हे असं असणार आहे, बरोबर ना. मग हे पुलीचं टेन्शन झालं, हे मासचं टेन्शन झालं, मासवरती ऍक्ट होणारं टेन्शन, म्हणून हा टी काय आहे माझा अपोजिट आहे एक्सच्या. आणि इनर्शिया फोर्स काय असतो? mx डबल डॉट. मग mx डबल डॉट काय झालं? अपोजिट टू द डिस्प्लेसमेंट. आणि हा थोडा टी काय झाला म्हणजे दिस टेन्शन टी इज नथिंग बट एक्सटर्नल फोर्स. दिस टेन्शन टी इज नथिंग बट एक्सटर्नल फोर्स विच इज ऍक्टिंग ऑन द मास एम. म्हणजे जसं एखादा स्प्रिंग फोर्स ऍक्ट करत तसा. ओके, तर मला कळलंय का बघा. अँड नाउ आय विल सॉल्व द प्रॉब्लेम. ओके, सो व्हॉट इज D'Alembert's principle? Summation of inertia force plus external force is equal to 0. What is external inertia force? T plus external force, sorry, inertia force काय तुमचा mx डबल डॉट plus what is external force? T is equal to 0, right? Now T plus mx double dot is equal to 0. T किती आहे? T is equal to kx plus 4 plus mx double dot is equal to 0. ह्याच्यावरनं मला मिळतं x dot plus k upon 4m x is equal to 0. Comparing with the standard equation, equation काय मिळालंय मला? बघा, equation काय मिळालंय मला? equation मला मिळालंय x double dot plus k upon 4m x is equal to 0. So omega n किती झाला? Rate of k upon 4. आता मला सांगा